Welcome back. We are going to see IP addressing and subnetting in this experiment. Previously, we have seen what is an IP address, if you would have remember. So, IP address is a series of number that is used to identify any device on a network. Okay, it is uniquely used to identify any devices on a network, right? Then we saw what is the network address. Then we saw what is the broadcast address. Network address is the starting address of a particular network, and the broadcast address is the last address that is being used, right? So typically speaking, about any IP addresses, there are going to be two type of IP addresses. One is going to be IPv4 and IPv6, and predominantly for this experiment we are going to go ahead with your IPv4. So typically lots and lots of problems might be coming in. Just for example, binary to decimal conversion, decimal to binary conversion, and identification of the classes. Then your ultimate problem is going to be like this: number of subnets is 6, number of usable host is going to be host id is going to be 30, and the network address is like this. So you are expected to find all the questions which is enumerated here. So this is going to be like any set of experiments. Let's go how to tackle or how to perform subnetting in a sequenced way. Okay, and let's start. Okay, so typically starting in IPv4, there are going to be 5 classes, right? So A, B, C, D, and any IP address is going to have 4 octets, and each octet is divided by, with a dot, right? So in class A, the first octet is reserved for the network, as you have known, and in class B, the first two octets are reserved for your class B, and in class C, the 3 octets are reserved for uh, your network part. So your host part over here, it's going to be tremendous. It's going to be like the huge amount of IP address or host address is available in class A. In class B, it's going to be a equal part of your network and a equal part of your host. And in class C, the number of hosts in a network is going to get limited to only 255. Okay, so on just looking at the initial octet itself, we could tell which class it comes under, whether it's going to be class A, class B, or class C. So all these are widely discussed in the classes, right? And we know what is a private IP address for each class, what are the set of IP address that are kept private, and the default subnet mask for each classes are like this: 255.0.0.0. And for class B, the first 2 octets, that is, it's kept it as 255, and class C, it is the first 3 octets are reserved for your network part. That's why the subnet mask indirectly refers to the network part of that particular IP address. Okay, so in class C, the 3 octets are reserved for your network path. That's why it's the octets are fully given 1. That's why it's going to be 255. In class A, only the first part, the first octet is reserved for your network part. That's why it's given as 255. So on looking at just an IP address, you should be able to say which type of classes it belongs, and looking at the subnet mask, it we can tell which category it is in, or whether is it following the default subnet mask or any subnet mask is changed. Okay, and here we can represent the same IP address of class A with, say, a class IP /8. Okay, that /8 refers to this particular subnet mask also. For class B, it's going to be any class B address slash 16, and for class C it's going to be any IP address of class C /24. So if it is mentioned as 8, 16, and 24 respectively for these classes, then they are the default subnet mask. If any changes occurs, we are going to tell that the subnetting has occurred. So if any class address greater than /8, so if the subnet mask other than 255 is included here, we can say that if the network is subnetted. Okay, and here also, other than the two network path, if an subnet mask is added over here, we say it as an subnetting has occurred in this class B. And likewise, any changes in the 0 of class C IP address, we can say that and subnetting has occurred. So you might ask why subnetting is required. There might be an occasion where we need fewer number of hosts and more number of subnetworks. Okay, say for example, here the number of hosts are more. So if I want more subnets over here, I can take the host part and give it to the network part. So thereby indicating that we use this subnetting. Likewise, I can take the host part, give it to the network part, and whichever part I'm giving to the network part, and we indirectly denote out. So we'll give the most significant bit to the corresponding the other network part. So we'll discuss this in elaboration. Before that, you should be knowing how to convert a primary number to a decimal. Likewise, any decimal number to binary. Please look it up, and in a given scenario you should be knowing which kind of IP address class it belongs to. You should be knowing, and you should be in a given IP address, you should be knowing which is the network part, which is the host part. Say if it is the class B, the first two octets are reserved for the network part and the next two parts are reserved for your host part. So you should be easily able to fill this particular notebook, right? And given a subnet mask, you should be able to find the network address by performing logical AND operation between the IP address and the corresponding subnet mask. So with that, you'll be able to find out the first network IP address. Okay, this is going to be the scenario, right? Similarly, the host address here, other than the network part reserved, whichever IP address comes, it will be taken up as your host address. If you could see, this is class A address, and the subnet mask, default subnet mask, is supposed to be 255.0.0. However, if you see this particular is subnetted, this particular IP address is subnetted. It's no longer 10.10.48.80/8. It is 10.10.48.80/24. How am I saying 24? 8 plus 8 plus 8. So 3 octets are reserved for the network part in this particular thon. So the number of hosts available is going to be 80. Okay, the host address. Likewise, you'll be able to easily find out the host bit of this particular IP addresses. Now, looking at IP address, you should be able to tell what is the default subnet mask, and that will be also pretty easy for you. Now let's discuss about ANDing of your ANDing with the default subnet mask. What it's going to do, given an IP address, right? These are the various default subnet mask and how the AND operation occurs. So if IP address is given like this, so what you do, you should be able to say which is the host part and which is the network part. So this is the network part, this is the host part. Why am I saying it as a network part? Because this is being class C and the subnet mask falls under 255.255.255. That means what? The three octets are reserved for the network part. Only the 33, that is this particular part, right, ranging from 0 to 255 is allowed for the host part. So I can say that in confidence that this is the network part and this is the host part. And how will I find the first network? I should say the network address, take the subnet mask, take the IP address, write the converted decimal, not binary format of it, and take the subnet mask and kindly add it out. So once you are able to add it out, you'll be able to find which is the corresponding network address. Likewise, this is the previous one was performed for a default subnet mask. Now we'll do the same thing for a custom subnet mask. Okay, that means what? The default subnet mask is no longer used. Rather, we are going to add in certain data. Say the host part of the IP address is taken up for the network part. Here 240 is there. That means what? these many address ranges are available. Sir, what are you saying? Say what happened over here was the subnet mask, the default subnet mask is like this 250 until this particular part 255.255.255. This being a class C address, it's going to remain same. Then if you would have spotted this 240, what is that 240 is nothing but 240 is nothing but this particular most significant fits are taken up as 1. So when you convert this thing, this converts to 240. So it is the subnet mask. If you are going to take this particular bit from the host part to the network part, we say it as subnetting. Okay, so default subnet mask for class C is going to be 24, right? So if I take the first bit, it's going to be 25. This is going to be 26, 27, and 28. So if I say this IP address slash 28, that means I have taken 4 bits more, 4 significant bits for the subnetting part. So it's represented like this. Now if I AND it out, I no longer get 0 as my network address. I get 32 as my address, because when I'm going to add it in, right, I get the new network address for the corresponding thing, because the entire network now is no longer has one network and 255 host. Now as it is taken up 4 significant bits of the host address, 2 to the power 4 networks are possible, and 2 to the power 4 number of hosts is available for each and every host network. Okay, so let me repeat once again. So 4 significant bit is taken for the network. So how will I calculate the how will I calculate how many subnets are there? So uh, part whichever uh, part of the particular IP address is taken up for the subnetting, so I have to take the number of ones for it. So here it's going to be 4. That means 2 to the power 4 number of subnetworks are possible. 2 to the power 4 is going to be 2 to the power 4 is going to be 2, 4, 8, 32 sets of IP address is possible, right? 2 to the power 1, 2 to the power 2. So those many set of IP address, I mean 16 set of subnetworks are possible, and in every network 16 hosts are available. So this is the powerful nature of subnetting. So why do I do it? So it's based on my requirement. If I've given a IP address, if I want multiple networks to be done, I can do this subnetting. So doing this, I'll be able to specifically target the number of IP address which is required. Why it is required? It is based on the demand of the requirement. Okay, based on the demand and requirement, we are going to do this. There might be a certain requirement like I need only 5 networks, so we can't go ahead with that. It is going to be either 2, 4, 8, right? So because all these things are the networks are being allocated like this, the subnet is also going to work ahead. So how to determine the number of subnets and the number of hosts? The formula is going to be 2 to the power s. What is this s? S is the number of bits allocated for your from the host part to the network. Here it's going to be 4, so 2 to the power 4 number of subnets are available. And how many hosts are available? The remaining number of numbers which are available are taken up as your host. So 2 to the power of host minus 2. So what does it imply in this two numbers? The usable part, you have to negate the network part and the last broadcast address. That's why this particular thing is going to be done. Now let's quickly go into your example such that you might understand what is going on. Okay, see, this is subnetting an example. I have taken the normal class C address, class 24, that is nothing but 255.255.255.0, right? So here the number of subnets available, right, there is no changes at all. The actual thing is the default mask is going to be 24, and the actual mask given here is going to be also 24. So 24 minus 24, so the number of significant bits is going to be 0. So the number of subnets, the formula is 2 to the power s. So the s over here is 0. So 2 to the power 0 is going to be 1. So there are going to be only one subnet in this particular IP address declaration. So how many hosts are available? So remaining 24 bits are available. That means 8 more bits are available for my host part. So 2 to the power 8 minus 2, that is nothing but your 2 to the power 54. So if I start with my first IP, it's going to be 1.0. Okay, how do I find it out? Take the IP address and subnet mask, perform AND operation, I'll get this particular address. And from there to 255, right? This is the last broadcast address, and before to that is the last ending IP address I can use, and the starting IP address which I can use is from 1.1. So this is my network address, this is my broadcast address, the first usable address and my last usable address. This is for if it is going to be subnet 1, right? For each subnet this is also applicable, right? So we'll see a next example. In the next example, the same IP address I have taken, but I have taken this subnet mask, or the network ID has to be 25. So what does it imply? The default mask is supposed to be 255.255.0.0, right? Sorry, 255.255.255.0. But here, when I say 25, I am taking one bit from the network part and giving it out here. So what happens? The subnet mask, my custom subnet mask is going to be 255.255.255.128. That means what? I have taken one bit from my host part and given to my network part. So let's see how many bit I have allocated. I have allocated one bit. So how will I know? Take the subnet mask over here, apply it here. What is the default subnet mask? It's going to be 24. So when I'm going to minus it out, it's going to be 1. So the number of subnets is going to be 2 to the power 1. That's going to be 2. So how many subnets are available? 2 subnets are available. So how will I know which is the subnets, how, where it will start? So here either it could be 0 network or 1 network, because this is a significant bit, right? As I have given it to the network part, so this could be 0 or 1. So the range of IP address could start from 192.168.1.0, and it will end with 192.168.1.0 all ones. So this might be coming around 127 if I'm right. And whereas the next IP address subnet address starts with 192.168.1.1.0, I think this should be 192.168.1.128. So this is the network address for the second subnet. Okay, likewise you will be able to calculate for each subnets. Now I'll go to the third example, right? So we'll once again see how the subnet is being done, right? So in each subnet, how many hosts? So the number of host is going to be 7, right? So I have allocated one thing to the network, remaining number of hosts is going to be 7. That's why 2 to the power 7 minus 2, so 126. So the network IP address, as I told, it's going to be 1.0, and it ranges from 1.1 to 126, and the broadcast address is going to be 128. And the second thing, it starts with 128. Don't mistake me, I have made a mistake. It's going to be 128, and the usable part is going to be 129. Yeah, and it should be corrected, right? How it's 128? It starts with 1000. So the second subnet is going to be taken up as 128. I can't use this because this is a network address. Correspondingly, I have to go in and use this particular set of IP address from 129 to 254. 255 is the normal broadcast address. This is your second example. Third example, instead of 25, let me make it as 26. So what does it imply? 2 bits is taken from the host part and given to the network part. So this 2 bits is taken up. So what are the various combinations that I can go ahead with this 2 bit? So it's going to be 00, 01, 010 and 11. So I can make 4 subnets out of it. So what are the corresponding IP address? It's up to you to design, right? So the first set of for the subnet, it's going to start from say 192.168.1.0, and it will end with 192.168 1.00 all ones. Then once again, my second subnet will start with 192.168.1.01 and all these, right? So you should be easily finding out how many address are available. Okay. And one of the possible questions to you could be, given an IP address, in which subnet does it come in? Say for example 1.5, so 1.5 will naturally come under the subnet 1. So this kind of questions also could be asked. Now let me go to your example 4, wherein I have taken say three subnets over here. So here three subnet, in the sense there are going to be the regular thing is going to be, the given subnet is going to be 27 and the default subnet mask is going to be 24. When I minus it out, I get 3. So 2 to the power 3 is going to be 8. So how many combinations are possible? 8 combinations are possible. So based on this, I can have my network address, starting address, last address and broadcast address. Likewise, I can find out for each network, so I'll be easily able to do it. Until now we have been discussing up with type C. Now let's do it for class B address. Okay, the default subnet mask is supposed to be 255.255. However, we have taken up say 24. That means what? Another subnet mask. These many addresses are borrowed from the host part. So let's find out how many subnets could be made with this particular thing. So it's 24, right? 24 minus the default subnet mask, it's going to be 8. That means 2 to the power 8, 256 subnets are possible. And each subnets, it's going to have how many networks? It's going to have how many hosts? It's going to have 256 individual host minus 2, that is 254 hosts are available. It's 2 to the power h minus 2, right? So here it's h is going to be 8. So 8 is going to be 256 minus 2, that's going to be 254 hosts in each networks. So totally 256 subnets are possible in this particular example. So let me go with another example. This is class A IP address, if you could see, and here I have given it as /9. So default mask is going to be 8, and here I have taken as just 1. So let's see how it works. So the default subnet mask is going to be like this. And if it's going to be an IP position, it's going to be 255.255.254. That means how many subnets are possible? Two subnets are possible, because the number of subnets allocated, the host I mean the network, the bit allocated is 1. So 2 to the power 1 is going to be 2 subnets. So how it is going to be? It's going to be 12 dot, right, all zeros. This is the starting address of my first subnet, and my second subnet, what is the starting address? It's going to be 12 dot 128 dot, it's going to start like this. Okay, this is my subnet. So how many host address are available here? It's going to be 8 8, and here instead of 8, it's going to be 7. So it's going to be 2 to the power 23 hosts are available in this particular subnet, and here also it's going to have 2 to the power 23 host. Okay, now you might have a question, in which subnet does this particular IP come in? You can clearly find it out. So 12.168 doesn't come under this particular set of IP address. It comes in the subnet number 2. Now I hope I have given you lots of examples for you. Kindly fill out that particular chart which we have given to you for practice. Kindly do fill it in. For any queries, you can come back to our classes and discuss. Thank you. Have a nice day.